in the name of maths, and this is one of the success there itself. So before I start, I just quickly some housekeeping stuff. Any question for the time being, just hold on to that, or you can put it in the chat. As soon as I'm finished, I'll take as many questions as I can. You can actually email me or put it in our WhatsApp group and all those. I would always love to engage in maths discussion because I always learn from that. So please feel free to share your thoughts, your ideas, questions, anything. And there is no such thing as stupid question. All questions are very, very important questions. Okay. So before I start, I'll just request everyone to mute your, audio if you can, so that there's less disturbance, and then I'll go right into it. Okay. So let's start. Let me share my screen. I can see some of you have joined from India, which is now it's, uh, it's early morning. So special thanks for them. Okay. So everyone can see my screen, right?
দেখতে পাচ্ছি সম্ভবত।
Okay. So I will actually try deliver that in English. Sometime I will break into Bengali just for the fun of it. You can ask me question in any language you want. Okay. So as I started, I'll first tell you. In fact, I chose this title, Mathematics. Who cares? Now, in this whole talk, I'll try to prove that maybe it is worth caring about it. So let's see. So I'll start with this sentence. It is not mine. It has been around for some time. So everyone was a gifted mathematician before they went to their school mathematics curriculum. It is actually very true. Every child is curious, and we as a human, we are born with a gift of recognizing pattern. Mathematics is nothing but the study, or I would say exploration of those patterns, maybe in a more generic, more abstract, or in a more detailed way. Mathematics not necessarily has to be finding pattern with numbers. It can be anything. So before that, I want to share a funny clip I just got today, and I could not help but sharing with you. See if you can actually see.
2 - 2 कितना होता है? यही तो पूछा था तुमसे और तुम रोए जा रहे हो। कितना होता है 2 - 2? अभी तुम्हें लंच में मानो तुम्हें 2 रोटी दी मैंने। तुम्हें लंच में मैंने 2 रोटी दी और तुमने 2 खाई। क्या बचा?
Okay.
Two.
So going back to that. So basically, this is probably you have experienced that as a child or with your child. So this is the idea, the kids always have many questions, and if we just force them to learn something in our way, or the way mathematics is being taught, that is not actually correct. They are asking questions, they are trying to find a pattern. If we cannot, try to go along with them, try to explore, and that is the way they will figure it out, you will figure it out, and actually that is where the journey of mathematics starts. So what is exactly mathematics? Before that, more interesting question will be, what is not mathematics? And it will be surprising for you what I'm going to tell right now. So very often we are yes. Yeah. So very often I have seen people test someone's mathematical skill by testing them with, multiplying with two big numbers or adding big, gigantic numbers in their head. And if they can do it, they are good in mathematics. Nothing can be far from the truth. This is not mathematics. This is arithmetic. This is numeric skill, which is good to have, but that is not mathematics. Actually, most of the mathematicians are really bad in fast calculation because they do not do that in their mathematics research or any other mathematical exploration. So this is not mathematics. Solving very big equations, these scary looking things, mathematicians don't do that. Actually, I don't know any of the mathematician will actually try to solve this because computer can do that. And that is absolutely not mathematics. Some interesting things can be done with it, but solving it is a very boring thing. These are not mathematics. Even these big, all those big names, calculus, trigonometry, and all those, well, we do use that sometime, but they are not interesting mathematics. In mathematics world, we call them techniques, basically byproducts of mathematical thinking. We do not use that. People from other professions like physicist, scientist, economist, accountant, engineers, they use that. Mathematicians, they try to avoid those type of big calculations or even those, scary looking calculus and trigonometry. So, what is exactly then mathematics? If I tell you this is actually very interesting mathematics, Feluda, Sherlock Holmes. Why? Because here you are connecting dots. Apparently, there are chaos, there are unknown things. You are trying to find patterns out of it. Connecting dots, connecting objects, connecting properties, many other things. This is interesting mathematics. Actually, there are a branch of mathematics called graph theory, which deals with that. This is definitely mathematics. In fact, I am planning to give a separate lecture on the mathematics of music. Every musician in the world is a mathematician, only thing they don't know it. I a quick trivia question. Any of you can identify the artist? Anyone? Anyone? No? Okay, I'll give you the answer. So this is by one famous Dutch artist. His name is M.C. Escher. He never called himself a painter or an artist. He always called himself a mathematician. So he was basically an architect, draftsman, engineer, and all those. But he preferred to call himself mathematician. So I'll tell you some of the interesting things about his painting. He used many different concepts, which one of my research area is called computational geometry. So he played with different concepts and very interestingly put it in some paintings. So if you see this left image here, see one guy is climbing down these stairs and one guy is climbing down these stairs. One guy is climbing down these stairs. One guy is climbing up. If you zoom in and only look at those figures, it makes sense. But if you see it as a whole, the entire perspective is jumbled up. So that is an interesting thing. Another thing is, in any drawing, you see there is a figure and there is background. So if you see that this figure, so there is a hand, so that is the figure, and this black part around that are the background. Now look at the top image. Here, this black area is the background. And if you slowly move from right to left, this background becomes the actual figures, and vice versa. This white thing, if you go from left to right, it changes from background to actual figures. So many of these different concepts he used it in his art. Oh, this is one of my favorite. This is of course the great Messi, and this is extraordinary mathematics. So actually it is, you know, so this is a pass he is doing, and you know this guy is following that, and think of that, these other guys will be moving towards that bottom and all those. There are different kind of mathematics those are used here, though Messi is not thinking about it. But if you want to analyze it with mathematics, you will find beautiful mathematics in it. There are things called graph theory, Voronoi diagram. There's a thing called swarm intelligence is a very important concept in AI. Many other things, but you know, he's using that without knowing. So all those I talked about, these are beautiful application of mathematics, but I still did not tell you what exactly is mathematics. These are applications, nice. This is of course also, you know, the stock market analysis, probability and all those. This is a social media network graph. All those are useful and interesting mathematics. But what exactly is mathematics? So I'll use this one to explain in a very simplified way. See, we live in a place and in an environment. So continuously we engage with it, and we collect data through our sensory organs, right? So that's how we interact with our environment. This is the part, this middle part is where our life is. So with those data, we use technology, science, business, and all those things we do. Mathematics is actually outside of that. So with mathematics, we look into our everyday life and try to formulate that out, staying outside of the life. Why I mention that, if you think mathematics is actually a branch of philosophy, it is not a branch of science. Many people actually make that mistake. Mathematics is closer to poetry or painting than to science or engineering. So philosophy, using philosophy, we build mathematics. With mathematics, we build many different useful formulas and other things that scientists, business, and technologists, they use that. But they do not do mathematics. They use the mathematical things. They are maybe good in mathematical techniques, but that is not mathematics. Mathematics is more abstraction, generalization. So uh, maybe one analogy will be uh, not following the rule is a good mathematics. Maybe creating new rules, being a rebel, may be a good trait of a mathematician. Okay. So now how mathematics works. So you can start with a definition. Any definition is fine as long as they are consistent and clear. So you can say gravity does not exist or Santa Claus exists. Absolutely fine. There's no problem in mathematics. As long as you define it very clearly with all the properties and everything. Then there are things called axioms, which uh, universally we can think as true without any other proof or anything. For example, if I say someone's height is same, so person A's height is same as person B's height, and person B's height is same as person C's height, then person A's height is equals to person C's height. This is this cannot be proven. This you have to think or assume that is true. These type of things we call it axioms. With axioms and definition, step by step deductive reasoning, we uh, observe some facts. If those facts are very generic in nature, very useful in nature, we call them theorems. Sometimes if they are small, we call them lemmas and corollaries and all those. But basically, you can all call them proven facts. You can also use whatever already have proven to prove a new theorems. This is how mathematics works. Because basically, you start with definition and then you use your only deductive reasoning to come to the new theorems. In this process, we do not care about data. It might sound interesting. Mathematicians, any proof or anything, it does not deal with data. If I tell you prove that in a two-dimensional plane, the sum of angles of a triangle is two right angles. You can experiment with millions of different triangles and show me, okay, this is what happens. It is still not a proof for mathematics. Because what happens, what if the next experiment fails? And I tell you an interesting thing which in data science we use a lot of time. Maybe we'll also talk about that later when we talk about AI or data science. So there is a phenomenon called black swan. So basically we all know swans are white, right? So that is what everyone thinks, and with all the observations in the world we have found that swans are white. But when people went to Australia for the first time, they found some swans who are black. So basically, what I'm trying to say is that observation of the data coming out of that observation is good for statistical uh, uh, truth. It is not a mathematical truth. And of course, opinion is not mathematics. I wanted to highlight that part because sometimes we think that this is true because everyone believes that or everyone uses that. So that must be true. That is not mathematics. So why I'm saying that, you have to be honest enough and I would say uh, brave enough to think that whatever you know may not be correct, and you are ready to go through this logical rigor to see if that is correct or not. Now, this brings to the next one. So you want to reason something to prove your claim. So from the definition and from the axioms, you can go into many different routes, okay? But you want to go, all those routes are perfectly fine because they are all deductive reasoning you are giving. But you want to zero in to your claims. Basically, you want to prove something, okay? To do that, you have to actually go into an unknown territory to get into, to go in some, El Dorado place where you want to reach. But for that, because there are millions of different options available, you need to be intuitive. And that might actually really be very surprising for you. The biggest skill or biggest, I would say, friend of a mathematician is intuition. That might be very, very weird thing. Without intuition, you cannot do actually higher mathematics. You can understand mathematics without intuition, but you cannot actually build new things. Intuition is very important. So it is, sometimes it is actually seen that the mathematicians possess more imaginative brain than the poets. Okay. Only thing, though, with those intuition, you have to have those rigor of logic to establish your claim. That's it. So next one, okay. So before that, any question on that, or should I continue? Maybe I'll take that at the end. Okay. Okay. Next one. Sometime, if you think in a, or if you're not afraid of complexity and you want to think in a more complex way, sometimes it makes it simpler. I'll give you two examples. So there is a theorem, that three circles and there are common chords for each two pair of circles and they intersect. Doesn't matter, do not put too much thinking in it. What I wanted to say is that if you want to do it prove it in a classical way, it is very complex. All those things you have to bring in this, that. But interestingly, if you think that as a 3D sphere, transparent 3D sphere, okay, and immediately you will see visually that they will intersect each other. And when they intersect each other, there will be a common chords. And those three has to also intersect in one common point. And that will be the proof that all those common chords has to come to one single point. So they have to be concurrent. And that is actually a valid proof. 3 lines. Sometimes we use that in data science a lot. Say, for example, there are two different items, red and blue, and you have to come up with maybe a simple function to isolate them. So you have to come up, you cannot have a linear function doing that because you need a curve. But if you project it in a higher dimension like this, okay, so you see, then in 3D they can be isolated very easily because it can reveal the difference very clearly, and you can have a hyperplane which is still a linear function, and you can just isolate them. So without going into those jargons and all those, what I'm trying to say is that sometime if you dare to look from a complex perspective, actually the problem becomes very simple. So for that, you need little bravery to do mathematics. Here, this is a very important concept I want to highlight. In mathematics, we do not care about reality. We care about truth. And again, what do I mean by that? Reality is very uh, relative. What you see from that point of view, that is real to you. But if you change your perspective, your frame of reference, reality changes. This is, some example from where you are looking at, things will be different. Now, truth, when I mention the word truth, this is very uh, confusing thing because there is no such thing as absolute truth. Whatever you have defined within that context, what automatically follows, no matter what data you give, that you can call your general truth. Only for that, only for that context. Okay. So you can have any different type of uh, definitions you may want, and you can have your own truth based on that. Okay. Maybe we need a different type of discussion on that. But what I'm trying to tell you here is that you can come up your own truth as long as they are consistent. Okay. Now we talked about many different things about math. This is a funny thing. Uh, anyone knows about that guy? His name is Kurt Gödel. Anyone? Oh, Swarnadeep knows. Okay. So basically, this guy was a famous mathematician. In fact, he is considered one of the uh, most renowned logician. Like logic is one part of discrete mathematics. So this guy, with mathematics, proved that mathematics fails sometime. So there are some mathematical truth which can never be proven. Okay. So these are called Gödel's incompleteness theorem. So don't worry, it is only for some special cases. I'll tell you some of the funny thing. So here, if I take this statement and I say this statement is false, can you determine whether this statement within this yellow box is it true or is it false? If you say it is true, then this statement is false. It tells it's false. But if you say it is false, then the statement is actually true because it is telling it is false. So it's a self-referencing thing, which, that's where the mathematics breaks. It's same concept that right box is true, and if the left box is saying the left box, and right box is saying the left box is false. So which one is true? You cannot tell. So only in this, this logical paradox and all those, that's where mathematics fails. Otherwise, we are good. Now, here is one thing I want to mention. Mathematics is basically a language. Okay? It seems a little scary, but I don't know if any one of you have done little higher mathematics, you will immediately know that is the classic epsilon delta definition of limit. Whatever it is, don't worry about that. I just wanted to say, like, there are a bunch of symbols here, right? And it looks scary. I cannot figure out what is that. But it has a grammar. It has its own language. And it is not very difficult if you are trained in it, right? So mathematicians not always use that one. They can use English to describe that, something like this. Now you decide which one is easier, the top one or the bottom one, you know. But what I'm trying to say is that mathematics is a language, and most of the time, if you do mathematics, your language skill improves dramatically, exponentially. And actually, you can write poetry way easier if you do mathematics, because there are many things you can actually put there, and language also has a syntax, right? Vocabularies. If it makes it richer. And as I mentioned, that imagination is there. So mathematics is only for not for the right brain or left brain. It uses both the brain. Okay. So now, as I mentioned, that mathematics is a language, and you can choose whatever you want. You can choose to use symbols, or you can choose to use plain English. Mathematicians prefer the other way, the English thing. I'll tell you a personal story. In my PhD thesis, my thesis supervisor, he told me, okay, I don't know if any one of you used a thing called latex. So basically, it is like a tool where you can type mathematical symbols and it converts into a PDF, and it can converts into these mathematical symbols. So for that, you have to enclose that within dollar sign. So basically, you have to use dollar sign to type any mathematics symbols. Now he told me, for every dollar sign you put, you have to give me $1. So basically, he was discouraging mathematical symbol in a mathematics PhD paper, a PhD thesis. So that is funny, right? So, okay, with that, I leave you with the thoughts of, what mathematics is and not. We'll actually maybe elaborate in some other times. But it's time for some fun mathematical treatise. Okay? So this is one of the very famous uh, idioms we use in Bengali. Jaha bahanno taha tippanno. Basically, it says whatever is 52, that is 53. And I proved it. So there must be something wrong, but let's see if you can figure it out. So I just say a square minus a square equals a square minus a square, of course. And I take one a common out of that, which is fine. And with difference of two squares, I can write it like this. Product of their sum and the difference. Absolutely fine. Up to this is too fine. Then you see this a minus a and n minus a is common both sides. I cancel that. So I get a from here and a plus a from here. So I get a and 2a. Then, I can cancel a. Then 1 equals 2. Then 1 plus 51 and 2 plus 51, 52 equals 53. Proved. What is wrong in it? Anyone? There must be something wrong. It's easy.
Yes, I
Yes.
see. So
Yes.
on the right side, it's a plus a all times a minus a. But if you actually evaluate this, you get 2a squared
No,
minus
no.
2a squared.
Actually, it is not there. It is before that. See, this is the place where the problem is. See, we moved from second step to the third step by cancelling a minus a, which is basically 0. How do you cancel that? You divide both sides by 0, which is not allowed. Something divided by 0 is not infinity. It is not allowed in mathematics. Limit x tends to 0, that is a different thing. I'm not going there. But something you cannot divide by 0. So this is not allowed. If it was allowed, what would have happened? 5 times 0 is 0. 23 times 0 is 0. So 5 times 0 equals 23 times 0. So you cancel 0, 0, 5 equals 23. Doesn't make sense, right? So 0 is not allowed. Dividing by 0 is not allowed, okay? So that is one of the things.
What would a world with division by 0 allowed if 5 equals 23? Like that sort of
Yeah, so
nonsense look
everything
like.
will break. Okay. Okay. So next one, this is a little bit complicated. See if you can figure it out. We all know minus 1 times minus 1 is 1. Simple, right? So minus 1 whole square is 1. 1 square is also 1. So they're same. So I can take out the square. So minus 1 equals 1, right? So 1 minus 1, I add 1 in both sides. So 0 equals 2. I divide both sides by 2, allowed. Then 0 equals 1 again. Then I add 52. Then 52 equals 53. What is wrong in this? I did not divide it by 0 anywhere. So basically, this is where the thing is. If the base is negative, this is not always allowed. Why I mention this, not to teach you any maths or anything, basically, you need to be very careful in your thinking. Do not follow the steps. Okay? Follow the concept. You will immediately know. If you follow the steps which was, taught to you in school, you will have bad mathematics and sometimes wrong mathematics. That is what I just wanted to tell you.
বেসিক্যালি যখন তুমি আগের সেকশনে -1 = 1 করেছো, তো এটা যদি এটা এটা 2 = 0 হয়ে যাবে, -1
Exactly.
which
Yes,
is wrong.
exactly. Which is wrong. Why? Because this itself is not allowed. That's why it is wrong. আচ্ছা, এবার আরেকটা গল্প বলছি। Okay, so the circle can be a square. Can you actually relate to this one? I tell you a quick story, okay? Say, have you, any of you
So
been to?
that could be a perception, right? If we think in a 3D way, a circle, if thought
No, no, no,
like
no. No, actually not. I'll tell you this. Actually, I'll come to that. It's very interesting. Actually, if you see, most of the circle in our real life is actually a square. And I'm going to prove it right now. Say, I believe most of you or many of you have visited Manhattan, right? Or some place where there are grids, right? Say you and your friend is searching for an Italian restaurant there, famous Italian restaurant. You do not know where it is, so you are in a in an intersection. You asked a guy, a New Yorker, and hey, where is that? Oh, and he said, oh, nothing, just 1 kilometer walk. And everyone is busy in New York. That guy left, and now you are there, and you're thinking, okay, 1 kilometer. Uh, Walking distance, so it should be something within 1 kilometer radius. Good. So you said you go here, I go here, and when I find, you call me and I'll come. Okay, fine. So basically then you have to move within 1 kilometer radius, that you know. But if you move within 1 kilometer radius, you cannot move through the building. You have to move like this, right? So there, your distance measure will not be x square plus y square root. It will be x plus y. And if you plot that, that is a linear equation. So you will have a rhombus where the distance of every point, this x plus y will be 1, because that's how the distance will be measured in this case, in this Manhattan grid. So the idea is the distance we measure, it is not always a geometric or Euclidean distance. There can be many different way distance can be measured. Okay. So if we say unit circle, it can be any of this shape based on what type of uh, measuring function you are using. This is one of the thing called LP space. I'm not going into that, but circle is one of them. This round shape thing is one of them. In many cases, it can be any of those shapes. There can be even some weird shapes. I'll not go into that, but I'm saying with mathematics, you can prove circle can be a square. Uh, okay. Any of you know this? Okay.
I know.
Okay.
So
Yeah. So, okay. So basically, if you have a group where there are 40 or more people, it is guaranteed at least two of them will share same birthday. Almost guaranteed. You can actually bet. And 99.99% time you will win. And this word 99.99% is not my guess. It is actually the probability that can be calculated. So there is a concept called pigeonhole principle. With that, it can be done. But the idea is it's very funny, right? So you can try. Okay. You have seen this type of things before? This is one of them. There are many other things. So if you square this, 111 times 111, it gives you exactly a palindromic number. 1, 2, 3, 4, 3, 2, 1. So if you are multiplying 5 ones, the middle number will be 5, the pivot number for palindromes. And it can be proven. Okay. And there are many other mirror numbers and all those. Maybe another seminar I will talk about that. Fun things. Okay. This is another quick like puzzle, you can say. But the thing what I'm saying is You can get the answer very quickly, not a very big deal. But the answer will surprise you. The significance of the answer. Okay, so what is the biggest number? You can create with it with 3 nines. Addition, subtraction, multiplication, division, exponential, you can use. No factorial or any other fancy stuff.
Are we allowed to use numbers other than 9s, or is it like...
No, just 9. I will give that, that's, you can figure it out. It's not a very big deal. 9 to the power 9, that to the power 9. Okay? But that is not the fun. Here is the thing. How big is that number? Can you actually guess? It will boggle your mind. Be ready and take a deep breath. The total number of electrons in the universe is a pygmy beside this towering giant. And I can prove it right now. This number is approximately this, 10 to the power 380 million. And the total number of electrons in the observable universe is 10 to the power 81. You might think it is a very small number. It's not. In fact, it can be proven. Those who know little bit of science, you can figure it out. The highest atomic number, which means the number of protons, that means the number of electrons, is 92. That is uranium. Take 100, so 10 to the power 2. So you take a big molecule. In that molecule, there's 100 atoms. So 10 to the power, 1,000 atoms, say. So 10 to the power 2 plus 10 to the power 3. How much? 10 to the power 5. Like that, you multiply with very big number, it just gets added. So after some time, to go up to 10 to the power 51, you will reach Milky Way. And then after some time, so Milky Way is a galaxy. And if you take 100 billion galaxy, how much? You're adding another 10. So basically what happens, the exponential gets added, then do not get multiplied. So it's very difficult to push the exponential number on the top to a higher number. It absorbs the number, this power. And think of this power. It's unbelievable. Okay? So this big number can actually boggle your sense completely. Okay, and when we talk about big number, it comes to our mind that infinity. And this is a very funny thing, and it is true. All the numbers between 0 to 1, the number of numbers between 0 to 1 is same as the number of numbers between 0 to infinity, or any number between two numbers. This can be actually proven. Okay. In that, there are some infinities which are infinitely more than other infinities. I'll give you a quick intuition to that. You know integers, right? How many integers are there? Infinite number of integers. Right?
Countable infinity.
Yes, you know this, right? Okay, so what he mentioned is this countable infinity. So the integers, they are infinite in numbers, but between every integer, there are infinitely many numbers. So so the total number of numbers is actually infinitely more than the the integers. Okay. There are other small nuances of this that I can talk about that later. A quick thing, irrational numbers, right? Root 2, root 3, all those weird numbers. They are actually infinitely more than the numbers we use, the rational numbers. It can be proven, but later. Okay, another fun thing. Any of you know this constant? Okay, Shamnadeep, you know? Okay.
I'm going to take a guess here. It's how much the pitch of a note increases when you go a half step up, but like
Beautiful. Any musician in the house?
not
Okay.
in my house.
Okay. I'll tell about that, and maybe another day we'll have a seminar especially on the mathematics of music. So when we do music, so say something like sa, then komol re, then komol ga, like that. So every note, the the consecutive note of they are this multiple apart. So take this note. If you multiply with this number, then it becomes this note. If you multiply again with this number, it becomes this note. Why? Because there are 12 notes between, in an octave, including the sharp. So if you multiply any frequency with, if you multiply any frequency, no, sorry, if you take any note and I go to one octave higher, that is 12. That is uh, double the frequency. So if it is sa, it is higher size, exactly double the frequency. And you are actually multiplying it 12 times. So it has to be 12th root of 2, each one of them. So I'll talk about that later. I just wanted to make a quick fun thing. Here, you probably have seen this one. So math is not always about numbers. This is the hint. Can you guess what is the missing number here? I'm talking about number, but this is not numbers. You cannot actually numerically solve it. The kids might be able to solve it fast. Those who do not know the numbers, they might solve it quickly. Because you have to think in the other way. It's basically the shape. It's just the image was reversed. It's a parking lot. You saw that? It's actually 86, 87 like this. All the numbers are reversed. So you are looking at from the other side. Okay? Clear, right? You got, okay. I'll quickly talk about this one thing called Fermat's last theorem. Uh, Many of you probably know about it. So what happens, I tell you, this Fermat's guy, he was an amateur mathematician around late 16th century in Italy. So that guy used to do mathematics in his spare time, and he actually did many superb mathematical findings. 1 minute. Can you please translate into Bengali English? Oh, okay. Okay, that's fine. So let's just quickly talk. So this format guy, so he used to, like every other mathematician who were lazy, he used to write mathematics not in a notebook, but some place in his book, in some margin and something. So, and he never, most of the time, he never published anything. After his death, his son actually found all those things, and then he published. And out of that, there are many gems of mathematical observations we have found. On the last page, in the margin, he wrote this simple equation: x to the power n plus y to the power n equals z to the power n has no integer solution if the n is greater than 2. Simple thing. If n is 2, we know that theorem. a square plus b square equals c square, that happens. But anything more than 2 will not work. And he said, I have a very good proof about it. I can prove this one, but it is very little bit bigger and it won't fit into the small margin. That's why he left. Everyone forgot about it, and when it was published, people started to take a crack at it and could not solve it. It stayed unproven for 300 years or more. People got mad, some committed suicide over it. Generation of mathematicians actually, become insane trying to solve this one. So now this guy, his name is Andrew Wills. He is a professor in Princeton. So this guy literally closed himself in his basement and then locked himself for 7 years and came up with some proof. And there was a mistake in his proof. Someone found it and he took another 2 years and then he finally proved it. So now that was called the dreaded FLT or Fermat's last theorem. And there is one FLT-like theorem which is now currently making all the mathematicians mad. So this one, if it is proven, the internet as we know might not exist. All the security and everything might break. Do you know what is that problem? Oh, Sharnadeep knows again. Okay, tell.
The Riemann hypothesis.
No, it's not. So I'll tell you. This is called P equals NP problem. What does that mean? I tell you quickly. Say you put your password. Okay. So it is possible that how many characters are there in English? 26, and you can use different cases and you can use special character numbers and all those. So let's take 50 characters. Okay, and you have 8 character long password. So it will just, you can just try a for loop and you can try to break this. But if you make the password really long, it might take you years just to crack one password. Sometime even million of years if it is really big. So this type of problem cannot be solved in real times. Okay, so they are called NP problems. And those which can be solved in real times, they're called P problems, or I'll just use the word polynomial problem, but don't worry about it. Basically, the P problems can be solved in a very quick way, and NP problems cannot be solved uh, in a in a reasonable amount of time. But with clever mathematics, you can actually create some algorithms where the NP problems can be solved in P times. So basically, with some algorithm, you can actually transfer the NP problem to P problems. Now, no one knows whether all the NP problems can be resolved into P problems. Can be done or cannot be done, even that answers no one knows. So if P equals NP, then internet will break, because then everything can be solved. Your password can be hacked in no time. So no security will be actually safe. Though when I'm talking about password, the encryption and all those works in a different way. Factorization of big prime, even those which are NP problem can be solved in a second. So no one knows. So if you can solve, okay. Yeah, you have a question, Shanmadeep?
So what's the difference between NP complete, NP hard,
Oh,
and just
that
this NP section?
it will take you about 1 month to tell you. So not today. I'll tell you about this maybe someday. Okay. So let's talk about some personalities just to have some fun. So you know all of them? How many you can identify? Okay, I'll quickly tell. This guy is Euclid, that is Gauss, that is Euler, that is Pascal, that is Newton, that is Descartes. Whoever, this guy actually, this Cartesian, things, this guy developed. So this is, you probably have heard about them, but do you know any of those guys here? Some of you might know. You know this guy, right? Many of you know. Prashant Chandra Mahalanobis, right? The guy who, uh, you know, he founded that Indian Statistical Institute, but he was actually a famous mathematician. I talked about those distance measures. So he has one measured in his name called Mahalanobis distance. So he's actually a renowned mathematician among the mathematicians in the world. He was also a very good friend of Ramanujan. This guy is C.R. Rao. He recently got, which is called the Nobel of Statistics, uh, about, I think, 89 years old or something. Do you know this guy? This guy on the left? His name is Al-Khwarizmi. And the name algorithm was actually named after him. Okay. And he created a book called Al-Zabr. From that, the word algebra came. So he's called the father of algorithm. This guy, his name is John von Neumann. Actually, he's supposed to be way famous than all of these Newton, Einstein, everyone, but no one knows his name other than the, people in the mathematics community. He was a physicist, a mathematician, an economist, and many other things. An incredible genius. But anyway, a lot of people don't know about this. This guy's name is Dan Jing. I'll quickly tell about a funny thing that actually happened. So, like every other mathematician, he was lazy and he came into the class late. And almost when the class is over, and he saw two questions written on the board. Okay, and he thought, wow, another two assignments. I have to quickly note down. So he noted down the questions, and the class ends. So he went back to his room, started solving those, and he found they're really, really, really tough. Somehow he cracked it, and in a week he submitted his assignment. Now the professors came running into his room in the middle of night, and he said, "What did you do?" He got scared. He said, "No, I actually handed over my assignment, and I did it myself. I can show you the work." Then the professor said, "No, no, no. I wrote them down to tell that these are unsolvable. No one in the world could solve it. And you solved it." So this was the guy. His name is Danji. Uh, so, sorry. This guy next to him, so he actually created a thing called simplex method, which is used in operation research and in many other things, optimization and all. So that is one of the guy. This guy's name is Kormokar, but he's not a Bengali. He's Maharashtrian. He's also a legend in this operation research field. And I think everyone know about this guy, our very own Toronto. Anyone? Anyone? Who is that guy? He's the father of AI, Jeffrey Hinton. So our Toronto guy.
Yeah,
Okay.
he is Mr. Hill, Dr. Hilton.
Yeah. Okay. So now some fun thing about the personalities. So this is one of the guy, okay? He died when he was 19 years of age in a gunfight. Okay. And that the reason of the gunfight was, some so at that time, there was so for the love of a girl, basically. So he had to fight with his friend, and he died in the gunshot. But in 19 years, he created a branch of mathematics which actually changed the entire mathematics landscape. In 19 years, he did that. His name is Galois. Of course, he was a French. There's a thing he created called group theory. So it changed many different field of mathematics and engineering and science. Okay. This is one of the guy, he's a Fields Medal winner, 2014, born in Hamilton, next to our city. His name is Manjul Bhargav, and he was actually direct disciple of Zakir Hussain. So he was a famous musician also, and a Fields Medal winner. Actually, he's a rock star in the mathematics world. And Manjul Bhargav, his PhD thesis guide was Andrew Wells, that guy who actually solved Fermat's last theorem. So Manjul Bhargav, in his own admission, that he actually learned more mathematics in Sanskrit stories than the school curriculum. Actually, he told that he used to bunk classes, never went to school class, mathematics classes, because he found that it's not teaching mathematics. So that is his word. And so, if you can find his, some lectures, very interesting, very down to earth guy. Okay. This is one of the guy. He talked about Riemann hypothesis. This one, there are some problems which no one could crack. This is called millennium problem. 1 million, prize money if you can solve them. There is only one millennium problem have been cracked so far, and that guy did it. His name is Gregory Perelman. And this guy actually refused the prize, refused that millennium prize, refused Fields Medal, everything. Basically, he said, I kind of know how universe works, and you are trying to give me a prize. So he left everything, even left mathematics. Now he lives in a remote village with his old mother as a recluse. Any of you know this person? Actually, he's my contemporary, same batch. So he used to he was in St. Xavier's College in 11, 12. So 67 rank in IIT Kanpur, but he went to study electrical engineering. Then after 1 year, he said, I do not want to do engineering. So he moved to mathematics in IIT. So after that, he moved to UC Berkeley, did his PhD, then became a monk. And after he became a monk, then he became the highest honor of mathematics in India, Shanti Swarup Bhatnagar Prize. So again, another character. Okay, this is one of my favorite topic. So this image, she's a mathematician, of course, and uh, with this, the scripts on the top, this somewhere in the Middle East. So any idea who that can be? Okay, I'll give you the answer. Her name is Miriam Marzakani. Is the only female Fields medalist so far. Unfortunate, because there are a lot of very good female mathematicians. No one has yet big, received any Fields Medal yet other than her. But maybe someone will be in future, will definitely get one. But the main thing is not just her name or she being the only female Fields Medal winner. There's something about the image, the photo itself. That is one of the most, I would say, uh, historical photos in our present uh, modern times. So what happens, in Iranian government is a orthodox government, right? So any female photos, they cannot publish it as is. They Photoshop it with hijab and then only they can publish it. They cannot show the hairs. That is the only picture. Actually, after her death, actually she passed away because of breast cancer. But after her death, Iranian government allowed only this picture without hijab. It's remarkable. So, talking about female mathematician, this is one of my most favorite. Her name is Hedy Lamarr, and she was the topmost actress in Hollywood in her time. Uh, in many mm, places, she was considered the most beautiful woman ever born, whatever it is. But basically, she was a Hollywood actress. Now, she is also famous for another reason, not very famous in the world, but in a different community. So she invented something called frequency hopping techniques. And because of that, the Allied Navy actually won the World War II. So that actually made those Navy could avoid the detection of German radars. We use the cell phones because of our invention. Genius. No one knew about that. Everyone knew about her beauty and her Hollywood career. So she had other patents. She created some encryption tool with piano. Genius. One of my hero. Okay, talking about that, movie on female mathematician. So when I was in high school, at that time in DD1 at that time, Doordarshan, every Sunday there used to be some foreign movies. Okay, so one day I was watching one of that, not I just casually was watching something was going on in the TV. So that was the uh, title of the movie, A Hill on the Dark Side of the Moon. So I was not actually planning to watch the movie. It was casually going on. So the first dialogue, it started and I got hooked into it. So it went like this. So one lady, she was standing on the deck of a ship and looking into the ocean. So one guy came to her and asked, "Are you a model or an actress?" And she replied, "Worse than that, I am a mathematician." And I got totally surprised. Wow. Okay. It's very unusual lines. And it was a fabulous movie. It was on her journey as a mathematician. She was the first woman PhD. Uh, all the social and other taboos she had to face. Wonderful movie. Wonderful movie. So I remember that. Sophia. So come talking about another movie about maths. Any of you have seen this movie? Beautiful Mind is a recent movie. Actually, it was an Oscar winner movie on a mathematician named John Nash. He was the pioneer of one of the field. I also work in that field a little bit.
Russell Crowe might be the actor.
Game theory. Sorry?
The actor is Russell Crowe, perhaps.
Yeah, the actor is Russell Crowe. Yes, yes. So John Nash had a schizophrenia, very acute schizophrenia. Even with that mental, disorder, he could create fabulous mathematics. The movie is basically based on that. He actually got a Nobel Prize, even if he was a mathematician. So in mathematics, there is no Nobel Prize. There are Fields Medal equivalent to that. Sometimes it is coveted more than that. But John Nash actually got Nobel in economics because his mathematics was used to describe many of the economic features. Another beautiful movie is The Imitation Game, probably you have seen. It's based on the life of Alan Turing. So he created a machine which actually could break the Enigma code of the Germans. And that machine later became what we call computer. So he is the guy who actually developed that. So he was definitely a genius, of course, a mathematician. And we all know about this guy. So there was a movie, probably you have seen it, The Man Who Knew Infinity. Incidentally, that guy, Monjul Bhargava, he was the executive producer of that movie. Okay, so this guy, Terence Tao, he is now considered the greatest mathematician alive, arguably, of course, but is definitely a rock star also in the mathematics world. So this guy, at the age of 10 and 11, was a medalist in International Math Olympiad, child prodigy. And with him, there was this guy, Paul Ardos. This is a very interesting character, Paul Ardos. He is not affiliated to any university or any college or anything. He moves around the world, collaborate with different mathematicians, and publish paper. He has he has actually published most mathematical papers and collaborated most with other mathematicians. So there is a number in mathematics world called Ardos number. So basically, if you have collaborated with him directly, you get Ardos number 1. If you have collaborated with someone who collaborated with Ardos, you get Ardos number 2, and like that. Incidentally, I have Ardos number 3 because one of my co-author has Ardos number 2. So yeah, so basically Terence Tao and Paul Ardos here. This is one of the most interesting slide I wanted to show. All those guys, they never wanted to be mathematician. They actually hated mathematics. This guy, Jun Hu, he hated mathematics so much, he wanted to ever, after his high school, never wanted to see mathematics. He enrolled himself in poetry in university. Accidentally, somehow he got some glimpses of a mathematics class and all those. He went there. To cut the long story short, he got a full Fields Medal recently. Okay. Then this is Tadashi Tokaida, very famous mathematician, topologist. He has actually did his undergrad in language history. Okay. And he became a famous mathematician. Eric Demine is a Canadian, actually, Halifax guy. And the person next to him, his name is Martin. Martin is a high school dropout, but he now works in MIT mathematics department. Eric actually homeschooled by his father. He's a child prodigy. In 15 years, he finished his PhD, mathematics PhD. Now he's a professor in MIT. He learned mathematics only by origami. Unbelievable, guys. So those who hate mathematics or still hate mathematics might think other way. You still have, you know, you can still get into mathematics and be actually a very good mathematician. So basically, if you are hating mathematics in your school, understand those are not mathematics. Maybe you are in the right path. Okay. So I'll just quickly finish this talk. There is one topic I wanted to just touch on this, and it is for that I will give credit to Soporno, because we are talking about the name of what should be the name of our institute. So he talked about Pythagoras and all those, and then it gave me an idea why we should actually care about this Eurocentrism. What does that mean? So many of the invention, many of the discovery, many of the findings are attributed wrongly to Europeans, which were done by other people. Many of them are done by Indians. So you probably heard about the term Arabic numerals. And you say, oh, Indians invented zero. No, we invented the entire numbers system, not only zero. So Arabs were the traders. They got this from the Indians, and the Europeans learned it from them. And they call it Arabic numerals. And whatever they call, that becomes the norm. The Arab themselves never call their numerals. They call it Hisab al-Hind. And if you go into Wikipedia and other parts, everywhere you'll see it's called Brahmi Hindu numerals. Again, I do not have any agenda to prove that that Indians are best and all those. No. Basically, in present day there are certain talks, there are two divisions. One guy say India has done everything. They had, I don't know, like nuclear powered aeroplane in Mahabharata time, and other says Indians did not do anything. Both are wrong. Indians did a lot, but not everything. So did many other civilizations. So all I'm saying is that we should give the credit where it is due. Next thing, this Pythagoras theorem. Everyone talks about this Pythagoras theorem. There should not be any mention of Pythagoras here. Okay? So if you talk about who actually first mentioned it, it should be Sumerians. Who first applied it in a major application, they're Egyptians. Who actually formally defined it, they're Indians. And who actually have formally proved it, they're Chinese. Pythagoras is nowhere in any of this first thing. And it is not mine. It is actually Manjul Bhargava's speech. Okay? There are many different independent proofs. Pythagoras was one of them. He happened to be the first Europeans. And that's it. He got the name. So we should start, changing it. Should not call it Pythagoras theorem. Call it right angle triangle theorem maybe, but not Pythagoras theorem. Next one, this Fibonacci sequence, you probably have heard it. It appears everywhere in the world, in the nature. Fibonacci did not invent it. Neither he even claimed that he invented it. He also learned it from the Arabs, who again learned it from the Indians. Pingala, like 400 BC, even before Alexander, he first mentioned this series. Now, this came into light or into prominence because of a poetry problem. So you can use single syllable word, monosyllable word, or two-syllable word in a poetry. And there are many different ways you can combine them, but to keep the meter, like, sonnet, like 14 characters and all. So you can only do a fixed amount of, or a fixed combination of monosyllable and two-syllable word. Those numbers happen to be the Fibonacci numbers. And Biranko first found it after Pingala, of course, and Hemachandra, about 400 years before Fibonacci, formulated this and give many detailed things about this series. We should not call it Fibonacci series. We should call it Hemachandra series. Manjul Bhargava used that. Okay, so with that, I'll just conclude this here. Talked a lot. So this is one of the slogan I use a lot. Let's make the world a better place. Let's talk math. What does that mean actually? In the previous slides, long back, I told that math does not care about opinion. It has to go through a rigorous step-by-step reasoning. And there is no such thing as ego while you are doing reasoning. There is no such thing as my logic or your logic. It has to be a logic. If your argument is wrong, that's fine. You learned something. So if we can think in that way, if we can practice that way, ego cannot actually get into our society. The world will be a better place. If you are a mathematician, if you get into mathematics, it's impossible to have egos because you will know how much you don't know. So with that, I finish the talk right now. So I'm open for question if you have any.
থ্যাংক ইউ সোমনাথ দা। না সত্যিকারের মানে অনেক কিছু আমি জানলাম যেগুলো ম্যাক্সিমামই আমি জানতামও না, এন্ড সিনসিয়ার থ্যাঙ্কস। আমি জানি যে অনেকেই হয়তো অনেক কিছু নতুন জানলো। তো হ্যাঁ, ওয়েটিং ফর মানে কারোর যদি কোনো স্পেসিফিক কোয়েশ্চেন থাকে। হয়তো মানে যদি আপনাদের কারোর পরেও কোনো কোয়েশ্চেন থাকে, কারণ এটা মোর লাইক যে মানে আমরা নতুন করে আর কি মানে ম্যাথসের যে একটা মানে ম্যাথসকে ছোটবেলা থেকে তো ভয় পেয়ে এসেছি কেসিনাগের থ্রু দিয়ে, ওটাই আর কি আমাদের মানে মোটামুটি অনেক বাঙালিরই আর কি ভবিষ্যতের একটা অন্য দিকে নিয়ে গেছে, ভালো খারাপ জানি না, তবে ওইভাবেই আর কি। তো অ্যাকচুয়াল ম্যাথামেটিক্স কে পুরো অন্য পার্সপেক্টিভে দেখানো, যেমন মানে সোমনাথ এটা তো জাস্ট একটা আইডিয়া দেওয়ার চেষ্টা করেছে যে ম্যাথস মানে ইন্ডিয়ানদের অ্যানসেস্ট্রিতে হোক বা ওভারঅল কানেকশনই হোক, সেটা কিরকম ভাবে হয় আর কি। বাট মানে দিস ইজ, আমি এটুকুই বলতে পারি যে মানে উনি যেরকম ভাবে প্ল্যান করেছেন আর কি, এটা তো মানে মানে কোনো বলার জন্য ছিল না, জাস্ট ডিসকাশন হিসেবে ছিল আর কি যে এটা এরকম হতে পারে। তো সেটাই আর কি বলার, যে যদি পরবর্তীকালে উনি হয়তো আলাদাভাবে ভেবেছেন আর কি যে গ্রুপ ভাগ করে করে যা করার করবেন, কিন্তু মানে যে আইডিয়াটা যেরকম ভাবে উনি ম্যাথসটাকে যে পার্সপেক্টিভ থেকে নিয়ে যেতে চাইছেন, মানে নট ফলোইং দ্য ক্যারিকুলাম জেনারেল মানে প্রসেসে, কিন্তু অ্যাকচুয়ালি ইন্টারন্যাশনাল ম্যাথ অলিম্পিয়াড হোক বা ম্যাথ ক্যাঙ্গারু হোক বা যে জিনিসগুলো সবকটাকেই উনি আলাদাভাবে মানে সেগুলোর জন্য তো একটা প্রপার ক্যারিকুলাম ফলো করেই সেটা উনি ভেবেছেন আর কি ক্লাস 1 থেকে। এটা জাস্ট একটা মানে কাইন্ড অফ